through the SPUR program. And so I'll be presenting on one of the projects that I worked on this year called a lens model approach to the nonverbal expression of fatigue, which I helped manage with the EPIC lab and with Dr. Molly Rubin, who was my advisor, and Morgan Stozic, who is one of the grad students in the lab. So to start off, I'll be just giving a bit of a background on fatigue and how we conceptualize it. So it's commonly conceptualized as having an impaired ability to complete mental or physical tasks due to a lack of resources, which include energy or motivation that are needed to complete them. And it's important to be able to detect fatigue because it can pose a significant societal cost with medical expenses, as well as impair quality of life and daily functioning. So being able to detect and address fatigue could reduce these work-related errors and cost, and just improve overall quality of life and well-being. However, in order to be able to address these issues, it's important that we're able to accurately detect fatigue in others and be able to measure it. So one way to do this would be through the detection of nonverbal behaviors associated with fatigue. Nonverbal expressions are often known to be more objective and reliable compared to other measures, such as self-report measures of traits. Excuse me. However, the validity of this approach is dependent on the perceiver's accuracy in their ability to detect these traits and to accurately use cues that are related to fatigue. So there have been some nonverbal behaviors that have been linked to fatigue. For example, in one study, photographs with fatigued people were rated as having increased drooping corner of the mouth, swollen and red eyes, and wrinkles in the skin. However, one problem is that in the existing literature, there hasn't been a lot of research on the actual validity of these cues. And since these studies just look at the cues that people use, they don't actually look at whether these cues are actually related to the target's actual felt fatigue. So our research aims to kind of answer these questions. So first, we want to identify what the objective nonverbal behaviors are that are associated validly with fatigue. And second, we want to understand how perceivers are able to utilize these cues when detecting fatigue in others, and whether or not this detection is accurate. So to answer these questions, we decided to use a lens model approach, specifically Brunswik's lens model. And this model is used to represent the cues that are related to a certain variable, how people use these cues, and how valid those cues are. So here, ecological validity refers to the extent to which the cues expressed by the target are validly associated with the given trait, which in this case is fatigue. And cue utilization refers to the cues that are actually utilized by the perceivers when they're forming these judgments. And accuracy represents the extent to which the cues that are being used by the perceivers are actually related to fatigue and are accurate, which is the number on top. So for this study, we had perceivers rate videotaped interactions of undergraduate student pairs from the University of Maine. And in these videos, students spoke to each other and answered a few questions. And the targets were also asked to complete a self-report measure of fatigue. So from 1 to 9, they rated how fatigued they were feeling. And from these videos, clips of 10 seconds in length were taken from the first minute, the third minute, and the fifth and final minute of the interaction, just so that we could see if there were differences in nonverbal expressions throughout the course of an interaction. And so in total, there were 60 clips. Perceivers were randomly assigned to a set of 30 clips to view without sound so that they could just rate the nonverbal behaviors. And 7 trained research assistants, including myself, coded a series of nonverbal cues that were theoretically related to fatigue, which we'll get into in a bit. And perceivers also rated the extent to which the target in the video felt fatigued from 1 to 9. So these were the nonverbal behaviors that the perceivers coded. There were 2 types. There were micro behaviors and macro impressions. Micro behaviors are more of the smaller movements, such as eye movements or mouth movements, and whereas macro impressions are more general traits or impressions of an individual, such as being bored or distracted, expressive, etc. We, the perceivers, rated from 1 to 9 the extent to which each of these traits were present in the clips that we viewed. All right, and for the results, I'll be showing some of the lens models that I helped to create to illustrate the relationships of the nonverbal cues. Here it is zoomed in just a little bit. I know, so the text and the numbers are a bit small. So this is a global lens model representing the correlations across all time points. So the numbers next to the traits represent the correlation coefficient between either the target self-report fatigue on the left or the perceiver ratings of fatigue on the right. And the number on top is the overall accuracy of perceiver ratings compared to the target ratings of fatigue. And so a high positive correlation means high accuracy, and a low or a negative correlation means low accuracy. And the numbers in bold represent statistically significant correlations. So as you can see here, one of the first things we see is that there's very little accuracy overall when it comes to judging fatigue in general. So the correlation on top is negative 0.17. So we know that accuracy in general is very low. And so if we look at the specific traits and their correlations, we also see that there is a mismatch in the correct cues that are associated with fatigue and the cues that people are using to make these judgments. So on the target side, we can see that holding the head and being fidgety are positively and validly correlated with fatigue. However, perceivers are using many other traits that aren't actually related to target fatigue, like being bored, being sad, and other traits, and even being less fidgety and jittery, which is actually the opposite relation it seems to actually have with target ratings of fatigue. And so if we split these relationships across time points, the correlations change a little bit. As we can see here in the beginning, holding the head is strongly associated with target fatigue. However, perceivers don't actually use that cue when they're judging fatigue and instead use other nonverbal behaviors that aren't validly related to target fatigue. So overall accuracy is very low at negative 0.32. And if we skip to the end of the interaction, this is where correlations change a little bit. So on the cue utilization side on the right, we see that perceivers are yet again using the same kinds of nonverbal cues to infer fatigue. And on the left side, on the ecological validity side, we see that this time point, there are actually multiple cues related to fatigue. However, the correlations of the validity of the cues and the utilization of cues are almost exactly opposite all across. So in other words, the cues that we normally think are linked to fatigue are actually not, such as being ratings of being tired or bored, and the cues that we don't think are related to fatigue actually are, such as being expressive or smiling or engaged. So this leads to a very low accuracy score of negative 0.53. So we see throughout the course of an interaction, fatigue detection accuracy decreases, which is interesting because we would normally expect that accuracy to increase since we get access to more information of an individual as we interact with them, but that might not be the case in this situation. So just to summarize the findings, perceivers are unable to accurately judge fatigue in targets, and the cues that perceivers use to make those judgments are inaccurate predictors of fatigue. And also, fatigue detection accuracy seems to diminish over the course of an interaction, and the cues that are validly associated with fatigue are different across time points. And so there's a lot of work that can be done to better understand the findings of this study and how to expand upon them. So one way to expand upon this would be to look at verbal cues when analyzing fatigue and fatigue detection accuracy. So it's possible that the reason accuracy was so low in this study was because people only used nonverbal cues and didn't use any verbal cues. So it's possible that if we looked at verbal cues such as talking time, fatigue might actually present itself through those cues, so it might affect perceiver accuracy. And another way we could expand the studies to look at how we can improve fatigue detection in perceivers. So I recently learned that we've decided to expand on these findings and are planning on running a second study that tests different training paradigms to see if we can actually improve this detection accuracy in perceivers. So I'm still not sure how these paradigms will be designed or implemented, but I think that testing them will provide a lot of good insight on how we can improve this perception accuracy and therefore improve how we address fatigue. So there's a lot of interesting work that can be done to better understand how we express fatigue and perceive it. And I just wanted to give a quick shout out and thank you to everyone who helped support me during this program. So my advisor, Dr. Molly Rubin, Morgan, who led the fatigue project, also Dr. Michael, who helped with the organization of the program, and the mentees, and as well as all the SPUR mentees who helped make this program so fun and so exciting, wonderful, and as well as the rest of the EPIC Lab and the SPUR program in general who helped make my participation in this project possible. So, and I also just want to thank all of you for coming and being able to listen to our findings and our presentations.
Great job.
Yeah.
Always a fan of a Brunswik lens model. Let's see here. So we're going to open up for questions now from the audience. We can do this via chat or via the raise hand function if you'd like. So questions for Jenni on misperceptions of fatigue in social interaction settings. All right, Natalie Whitland first. Wow, do you have a sense of why people are so wrong about what nonverbal indicators of fatigue are? I'm curious about where these misperceptions come from. So that's part one. Also, do you have a sense of how much this generalizes to other psychological and physical states? Like, are generally people not good at this?
Mm-hmm. Yeah, so those are great questions. Could you repeat the first one? I'm sorry, I'm not looking at the chat right now.
A sense for why people are so wrong about what nonverbal indicators of fatigue are. So that's the first, like, why are they so wrong? And we can repeat the second one in a second.
Yeah. I was actually wondering that myself, and I think there's a possibility that potentially it might be through the modalities, since we did use like videos and people made these inferences over video. So it is possible that maybe these expressions of fatigue aren't able to be accurately detected over video, or as I previously mentioned, maybe there are more verbal cues that are that help with our perception of fatigue in other people. So that's another possibility. And I think another thing just might be that people may be hiding their expression of fatigue, or are compensating for their reduced energy, or maybe experiencing increased arousal, since as we could see, some of the behaviors that were associated with fatigue were those of increased arousal, such as being expressive and animated. So I think there's a possibility that people might be masking their fatigue through these kinds of behaviors, and that's why we're not able to create an accurate judgment, or we just have a stereotyped view of what fatigue should look like, but in reality, we don't actually express fatigue in those ways, and we actually use different kinds of behaviors that we don't normally associate with fatigue. So I think there's a lot of different kinds of explanations